It breaks a century of established aerospace software certification, exposes unencrypted flight buses to novel cyber-physical threats, and evaporates the existing legal frameworks for liability in the event of a crash. Airlines operate on razor-thin capital margins that are highly sensitive to labor costs. To satisfy strict flight and duty time limitations and maintain scheduling redundancies, European low-cost carriers must maintain a costly ratio of approximately 10 to 11 type-rated pilots per single airframe. To counter these margin-eroding forces, major aircraft manufacturers have aggressively lobbied regulators, like the European Union Aviation Safety Agency, to approve Extended Minimum Crew Operations, or EMCO. This table details exactly how these operational models compare. It measures a conventional two-pilot flight deck against the proposed EMCO standard and ultimately a fully uncrewed autonomous cargo fleet. The financial incentive is explicit. Extended minimum crew operations aim to reduce flight deck staffing to a single operator during the cruise phase, cutting crew overhead by up to 40%. To certify software where a failure would result in the loss of the aircraft, developers must provide objective evidence of 100% modified condition decision coverage. Every logical pathway must be directly traceable from the source code to the executable object code. Deep learning architectures, like convolutional neural networks, break this requirement entirely. A CNN does not operate on human-defined rules. It uses millions of statistical weights adjusted during training. Because requirements cannot be directly traced to specific lines of code, the decision-making process functions as an unauditable black box. To bypass this hurdle, regulators are attempting to establish new frameworks based on the concepts of design assurance for neural networks, or CODAN. This abandons classical verification in favor of a three-stage W-shaped development pipeline, emphasizing rigorous dataset curation and model architecture validation.